Because this specifically is talking about regular polygons. We're trying to find the area of regular polygons, Jack.
It's a polygon with all sides.
So all sides and angles congruent. So when we're discussing this whole section, we're only talking about regular polygons. If you encounter a polygon in the wild and it is not a regular polygon, these rules that we're going, the area rules, don't apply to that polygon. So I don't want you. It's like getting training by watching a video and then going out and trying to survive 2 weeks by yourself in the wilderness. It's kind of not the same. So I want to prepare you. I want to be a good survival guide with your polygons. So we're going to find the area of a regular polygon using no trig. We're also going to construct equilateral triangles, squares, and regular hexagons using our compass and a straight edge. So anytime we do constructions, guys, make sure if you have to draw a line for a construction, use a straight edge. If you freehand a line on a construction on a test, you'll get stuff points for that. The doggone compass has a straight edge on it. Just use it.
What if it's freehand, but it's so straight you can't tell?
I can tell. I've taken drafting classes. I know. Okay, so Shelby, come and hold on. Stand down. Side of a polygon. So let's put the center of our polygon here, right in the middle. It is in the middle of our regular hexagon. It's also the center of our circle that is circumscribed around. It's called C for center. The side of a polygon is an edge on the outside. We represent that with the letter S. That's here. S. S for side. All right, now shall we come and hold the radius of a polygon so we can put that in our notes. The radius of a polygon is the radius of the circumscribed circle. That's a lot of sirs. Circumscribed circle about the polygon. So you can put the radius anywhere as long as it starts in the center and touches the circle. For our purposes, I'm going to put it from here to here. I could also put it from the center to any of the vertices and still have the same radius. Because the vertices is where your hexagon or your regular polygon touches the triangle. All right, Max, you're up. Be careful. Now, you should be able to pull it. Don't let it go. Once you grab it, don't let it go. There we go.
Cool, Max, have you been practicing?
Comes in at lunch. Okay, I'm going to pull this like a champ. Okay, so the apothegm. On the count of 3, we're going to say that word together. It's called apothegm. Apothegm. 1, 2, 3. Apothegm. It kind of sounds like opossum, but it's apothegm. It's the perpendicular length from the center to the side. So the perpendicular length from the center to the side, and it's usually a little a. Little a for apothegm. What do we usually use big A for? Area. So we use apothegm is a little a. So it goes from the center to the side. The apothegm. Put that down, and Sam, you are up for central angle of polygon. is the angle with the vertex at the center. So if I were to put another radius down, the central angle would be right here, and we're going to call it big C, our central angle. So the central angle goes from the radius of one vertex to the radius of another vertex. It's that angle. And this one's for Jesse. Jesse, if I have a hexagon, how many sides does a hexagon have?
6.
6 sides. Hexagon is one of the favorites for test takers to use. And then Jack, here's just super, are you ready? Is your brain engaged and turned on? I don't want to surprise it. How many degrees are in a full circle? So if I went all the way around, how many degrees would I be rotating?
360.
Uh-huh. So 360. If I'm splitting that 360 up into 6 pieces, Nancy, how many pieces? Sorry, not into 6 pieces, not 60. So if I were splitting that 360 up into 6 different slices, how many degrees would be in each slice?
60.
What is 36 divided by 6? 6. So 360 divided by 6 is 60 degrees. Okay, so just note, hexagon has 6 sides, so the central angle is going to be 60 degrees. What if it were 5 sides? What if it were a pentagon? So a pentagon has 5 sides, so it has 5 interior angles. So it's 360 divided by 5 is 72 degrees. Okay, so your central angle is going to change depending upon how many sides you have. Okay. So example 1 says find the measure of the angles of a triangle, of this triangle, and the radius, which is here, and the apothegm, which is here, of the regular hexagon when one side measures 8 inches. So I'm going to circle all the things that we have to find. So we're finding, and this is a super good tip when you guys get a word problem like this on your test, to help you keep track. Circle the things you need to find so that way you can go, oh yeah, I have 3 things I need to find. Did I find those 3 things on my test? So I need the angles of the triangle, I need the radius, and the apothegm. All right. So, Clay, how many sides do we have here? What shape is this? Hexagon. So it has 6 sides. What is the central angle? Right? It's 60. So our central angle is 60 degrees. Now it wants us to find all the measures of the angles of this triangle. So if this is 60 and I cut it in half to put the apothegm, what's half of 60?
30.
30. So this little slice is 30. So if this is 30 and this is 90, what does this little guy here have to be? Has to be 60 degrees. So think about this. In our black triangle, this guy is 60 degrees. This guy is 60 degrees. What does this guy over here have to be? 60 degrees. So angles are all 60 degrees of that triangle. So in a hexagon, when we split it up into its central angle triangles, we get equilateral triangles. Yay! Okay. So that takes care of our first item that we're supposed to find. So now we got to find the radius. So, Madeline, if this is a 30, 60, 90 triangle, two of them from here to here is 8. What is the base of just our 30, 60, 90 triangle? 4. Okay. So 4 is the short side. Now, Grant, we want to find the radius, which is kind of our hypotenuse for our 30, 60, 90 triangle. Do you remember how to find the hypotenuse if we have this short side? Okay, so how are 30, 60, and 90 related? Because this is how I remember the 30, 60, 90 triangle relationships. How is 30 related to 60? Yeah, so there's a double. And how is 30 related to 90? It's triple. So that's just my little remembering tool, because 30 triples to get 90. The medium side, this guy here, is the short side times root 3. The hypotenuse is double the short side. So Grant, if our short side is 4, what's the hypotenuse?
It's 4, 8.
8, yeah. So our radius is 8. And that would be inches. The reason that makes sense is if all the angles of this triangle are 60 degrees, it's an equal angular triangle. It is also equilateral. So all the sides are 8. All right, Dylan, we've already used this property of double for our 30, 60, 90 triangle. Now we're going to use the root 3 property to find the apothem. So what would the apothem be if your short side is 4?
12.
Root 3. Close. But just put, instead of multiplying the 4 and the 3 together, just say root 3.
4 root 3?
Yes. Because all you do is you take your short side, you multiply it by root 3 to find the medium side. And that's this guy right here.
So you don't have to put the actual answer?
That is it. That's answer.
No, I know, but like do the actual problem. Like multiply 4 by square. You can just leave it like that?
Yes.
Oh.
Yeah. So if you know you're going to have if it doesn't say to round, because it'll tell you put your answer in decimal form and round to the nearest 10. If it doesn't say that, go ahead and leave it as in the root form. Okay. For you won't do it. Okay. And that's all. We'll move on to the next slide. All right, so now let's do formula. So we saw how to split up a hexagon, a regular hexagon. Now we're going to use those pieces of information to find the area. So the area of a regular polygon, doesn't matter how many sides it has, is 1/2 times the apothem times the perimeter. So when you find the perimeter, it's like finding the base of every triangle. That's why we do perimeter, because it's all those triangles added together. Okay, we're back here with our regular hexagon with a side of 8 inches. So let's put the apothem. We've already found the apothem. And Merck, what was the apothem for this? The hexagon we just did?
Oh, 4 is root 3.
4 root 3. It's the same. This is the same hexagon that we did on the previous page. Same guy. So we're trying to find the area and perimeter of the regular hexagon, and actually I'm going to find the perimeter first because I need that to find the area. So the apothem is 4 root 3, and Justin, if our side length is 8 inches, what's the perimeter?
8 times 5.
So,
8 times 6.
8 times 6, and that's 48 inches. So we found the perimeter. Now we're going to use the formula. 1/2 app. We're going to use the formula to find the area. So the area is 1/2 times the apothem times the perimeter. Half of 4 is 2. 2 times 48 is 96. And we leave the root 3 there. And that is in inches squared. Okay. For example 3, we're going to find the area and the perimeter of a regular pentagon with a side of 11.6 and an apothem of 8. Thank goodness they gave that to us because we're trying to go no trig to find stuff. So let's go, Kai. You got it easy. Let's find the perimeter. What do I have to multiply together to find perimeter? Of this pentagon.
Yeah. What was that? 11.6 times 8.
11.6 times the number of sides we have. 11 times 5 is 55. 5 times 0.6 is 3, and 55 plus 3 is 58. How about mental math today? Yay! My turn. Okay. The area is equal to 1/2 app. On your test, if you use a formula, please put that formula down so I know what formula you're using. On test corrections, if you use a formula, put that formula down so I know what formula you're using. Before you start plugging stuff in. So it's really hard for me as your teacher to figure out where you went wrong when I can't even check to see if you've written down the formula or used the formula correctly. Okay. So 1/2 app, 1/2 times the apothem times the perimeter. Half of 8 is 4, and 4 times 58 is 232 centimeters squared. Get ready, Peter. Are you ready? You got this. Got this. All right. The question is, if the side of a regular polygon is reduced to half its length, how does the perimeter change? And I got you on this one. Let's start with something easy. So say this pentagon has a side length of 10. Peter, what is half of 10? 5. So this little baby guy is 5 for its side length. Now, I'm not letting you off the hook yet. What is the perimeter of the big guy? 50. It is 50. And what's the perimeter of the little guy? 25. Now, those questions are worker level questions. They were, you had an operation to do, you did it. There was not a lot of thought. Here's where you can get promoted to manager. How does the perimeter change? It is half, or divided by 2 is fine. It is half the original perimeter. So if you guys are thinking about your future, being able to do the basic skill is like earning a basic wage. It's thinking about the next steps and being able to describe to somebody else how to do it. That's more of a management kind of problem. Okay. Example 5, we want to find the area of an equilateral triangle. We already talked about equilateral triangle, so I think I can feel pretty comfortable throwing down those, that each angle is 60. With an apothem of 14 centimeters. So think about this as a regular polygon living inside of a circle. Yeah, it's the Illuminati. I got you. It's fine. I see it. The apothem is from the center of your circle to the middle of your perpendicular middle of your side. So we want to find, we have the apothem, we want to find the perimeter. So we need the side length. Because if we use 1/2 app, we have the apothem, we need to find the perimeter. So this apothem is 14. I'm going to pull this little triangle out so that you guys can kind of get a feel for how we're going to solve it. So if this is 14, this is 1/2 of our side, so I'm going to call this like, what is B? And then this is the hypotenuse here. The distance from here to here is the radius of our circle, but we don't need that for this problem. But I want you to see that it cuts the 60 degrees in half. So what kind of triangle do we have? A 30, 60, 90. We know our short side is 14.
14 times square root 3.
Yeah. So this is going to be 14 root 3 for half of our missing side. What is it going to be for the whole side?
28 times the square root.
Uh-huh. So our missing side is 28 root 3. Because it's two 14 root 3s. Yes, sir.
I thought that you double the middle side and then you triple the
For the hypotenuse, we would.
Okay.
But we're wanting this missing side length here, the one on the bottom.
Okay. Sure.
So our triangle is laying on its side. So it's not, the one we had before was standing straight up. This one is on its side, so it changes the way things are oriented. The hypotenuse is always double, and then the medium side is √3. So to find the perimeter, we're going to take 28√3 and multiply it by 3 because we have 3 sides. And that is 84√3. And let's go ahead and say that's centimeters. Okay, so that answers none of the questions. We want to find the area. So we're going to use 1/2 app. Our apothem was given, it's 14. Our perimeter is 84√3. Half of 14 is 7. And 7 times 84 is 588. And that's centimeters squared. Little square here. You can see my lovely circle. I circumscribed about my square. Yay! It says, find the area of the square. We're going to try to use 1/2 app to do it. With a radius of 4 inches. That is this guy right here. So we have a different kind of triangle because what is the corner of one square? 90. What do I get when I cut 90 in half? 45. So this guy is a 45, 45, 90. How are 45 and 90 related? Double. So in this case, it's a √2. But the hypotenuse is equal to the side times √2. What do we have in this triangle here, the hypotenuse or the side? We have the hypotenuse, we need the side. So instead of multiplying by √2 when we have the hypotenuse, we have to divide by √2. So the side, or our apothem, is 4 over √2. So when you have the hypotenuse and you want the side, you divide by √2. But the cool thing is, this guy over here is also 4 over √2. Come on, buddy. So what is the side if this is 4 over √2? What is that doubled? Yeah.
4?
It's not.
I don't know. 8 over, it's still squared?
Yeah, because you have a common denominator. So when you have a common denominator, the denominator stays the same and the top adds together. Good question. So the side is 8 over √2. And if we want to find the perimeter, we multiply that by 4. Which is 32 over √2. Oh, sorry, that's the perimeter. And then we use 1/2 app to find the area. 1/2 times the apothem, which was 4/√2, times 32/√2 is the perimeter. Now we can combine them. When it's multiplied, we can combine them together. So the area is going to be all the tops multiplied together. 1 times 4 times 32. 128. Divided by 2 times √2 times √2. These two together give me square root of 4. What is the square root of 4? 2. What's 2 times 2? 4. So 128 divided by 4 is 32.
Oh, yeah.
Wait, so if those two did add up to equal the square root of 2, it would still be what? Okay.
√2 times √2 is square root of 4. What is the square root of 4? 2. And then 2 times 2. So knowing the difference between multiplying fractions and adding fractions, super important, which is the reason why we do this in the first place. Danny and Stevie, can you guys pass out the compasses? Okay, go ahead while they're passing out compasses.
If we gave us a radius of 4, why couldn't we have just said that the diagonal was 8? Since the square, both diagonals are 8. Just do 8 times 8 is 64, divided by 2 is 32. Why don't we just do that? That's so much easier. It's too easy.
You can do it like that, but then I wouldn't get to show you how to use 1/2 app.
All
right, when you guys get your compass,
Thanks, Danny.
put a circle of your choosing. It just has to fit. It just has to fit in this area here.
Oh, you already have one?
So you guys, with your compass, put a circle. The less talking you do here, the better it'll be for this assignment. We can get it done before the bell rings. So we got Danny, there's an urgency here. Okay, if you guys are not paying attention, you're gonna miss this and have to go back and watch the recording. Put a circle on your paper, go. It has to just fit in this area here. Don't make it bigger than the area you have. Make a circle with the compass. Don't freehand this. Make a circle. So remember, we're not freehanding our circle or our line. Do not change the distance of your compass after you make a circle. Keep the distance the same. Keep the distance the same. Keep the distance the same. Put a dot at the bottom of your circle. By the way, it doesn't have to be the bottom. We're just all going to start from the bottom because it makes it easier to explain things when we're all starting the same way. Do not change the dimension of your compass. Put the bullseye on that dot at the bottom. Put the bullseye on the dot at that bottom. Make an arc that intersects your circle. Make an arc that intersects your circle. Move your bullseye to where that arc intersects your circle. Make another arc that intersects your circle. Move your compass to the bullseye where that arc intersects your circle. Guess what we're going to do? Make another arc that intersects your circle. Move your compass to where that arc intersects your circle. That's what we're going to do. Make an arc that intersects your circle. Move your compass. Make an arc. And then you should be back. If you've done it correctly, you should be back to your original mark. Use your straight edge. Come on, buddy. Use your straight edge to connect all of your arcs. Use your straight edge to connect all of the intersecting. Yep, start at your dot, end at your dot. This will give you a regular hexagon. The important thing to remember is that you've got to use your radius. Come on, buddy. Yeah, we can do this in 3 minutes. This is easy. Okay. Make a circle in the area below. So you guys move to example B once you have your hexagon done. Draw a diameter across your circle. Draw a diameter. Put your compass on the edge of the circle where it touches your diameter and open it further than halfway.
Across your circle.
So it just needs to be more than halfway. We're doing a perpendicular, so it's more than halfway. Draw an arc above and below your center. Move it to the other side. Draw an arc above and below. We now have a perpendicular bisector. Use your straight edge. Come on. And draw a straight line through your perpendicular bisector. And then we'll finish this without our compasses on Wednesday. Go ahead and pass your compasses forward, please. All right, so put a dot at the top, bottom, and the left, and the right. Actually, kind of like northeast, west, and south. And then use your straight edge to make a straight line. Recording. I'm recording.
Oh. That's what I was saying.
And then there's your square inside your circle.